So the two primary equations that we have in this chapter is the wave equation, that the speed of which the electromagnetic wave travels, which is the speed of light, is equal to the wavelength times the frequency. This is just like a wave equation that we had in Physics 1, V equals lambda F. And we also had an equation that relates the size of the electric field and the size of the magnetic field. The electric field is a lot bigger than the magnetic field by the ratio of the speed of light, which is 3 times 10 to the 8. So these three equations just basically are plug and chug using these three questions. So I just plug and chug using these two equations. All right, so I've got a cell phone, has a frequency, that's F, of 1.25 times 10 to the 8 hertz. And we're asked what's the wavelength. So that's lambda. Okay, so C equals lambda F. I want to get lambda, so I'm going to divide both sides by F. So lambda is equal to C over F. So that's 3 times 10 to the 8 for C over 1.25 times 10 to the 8. So that's basically 3 over 1.25 or 2.4 meters. Okay, so pretty straightforward. What's the biggest mistake the students make when they do this? They look at the equation, they rearrange it wrong, and they do lambda is equal to F over C. Remember, when you do the rearranging, the C is always going to be in the numerator. All right, let's do the second one. So the second one is basically just the opposite. I'm told the wavelength, have to find the frequency. So my wavelength is 0.30 nanometers. And remember, we always have to put this into the SI unit of meters. So that's going to be 3.0 times 10 to the minus 10 meters. There's 10 to the 9 nanometers in 1 meter. So what's the frequency? Remember, C is always going to be in the top. C over lambda is equal to the frequency. So I take 3 times 10 to the 8 over 3 times 10 to the minus 10. So I get 1 times 10 to the 18. And the units for frequency is hertz. So wavelength is a distance. The unit is meters. Frequency, the unit is hertz. All right, so that's pretty straightforward. Let's do one where I use that second equation. So I'm told at an instant in time, the magnetic field, that's B in the electromagnetic wave, is 2.28 times 10 to the minus 8 Tesla. And I want to find the electric field. So my equation is E equals C times B. So again, just plug and chug. 3 times 10 to the 8 times 2.28 times 10 to the minus 8. So 3 times 2.28, I get 6.84. And units for electric field could be either newtons per coulomb, or it could be in units of volts per meter. Either of those is acceptable. So that's the limit of the calculations for this module. They're really very straightforward.